Okay, today what we're going to be talking about is IPv4 subnetting. Now, a subnet is a particular, is how we say a particular network. A subnet has several different parts. It has a network boundary, and it has a broadcast address. The network boundary is the actual IP address that begins the network, but it isn't actually included in the number of hosts or the host portion of the address. So I'll give you an example of what we mean when we talk about a network boundary. We're going to start with a common network. In this case, 192.168.1.0. Now, I say this is a common network because it's used in many wireless routers or other devices as a default address. One thing we know about it is it's a Class C address, but when we look at it, we notice this trailing 0 in the end. This is actually the network boundary. So I'm going to write this down here, and you can remember that a network boundary is the actual place which we subdivide the network, but we don't actually use it in our numbering. So if we were going to define this network, and we would, in terms of speaking about it, we would say it's a /24 network in this case. And I do that arbitrarily. I defined that it was a /24, meaning that all 3 of these octet bits, octets, are set and noted as the network portion of the address, and the host is that last portion. So we have 8 bits in which to work, and those 8 bits allow us to go to our other network boundary. In this case, it's the end of the network. It's also called the broadcast address. We call it the broadcast address because a network packet that is addressed with this address as its destination is going to be interpreted as needing to be broadcast out to the entire network. Now, once that packet is addressed to the 255 host, it's the broadcast address on the network. A switch is going to then broadcast that packet out to the entire subnet. It is an announcement mode for our packets, but in this case, it's just the last address in the octet. Now, it's good to know about 255 as being the broadcast, but we need to remember that based on the way we actually subdivide the network, 255 is not always going to be the broadcast number. That's going to change based on the number of bits we use to define our subnet. This is the very simple way, and this is the way to start understanding subnetting. This is a /24 network, and one of the things that you want to do when you think about subnetting is you want to memorize this value right here. Put this in your memory. Memorize it. Write it down on paper over and over and over. This is the /24 network. It has 256 possible hosts. So that is a starting value of defining subnets. What we're going to do is we're going to work up and down this chain like a continuum. So when we take this subnet, which in this case is composed of the 256 hosts, and we have 24 bits that define its network, we have a network boundary address, and we have a broadcast address. We're going to have one more address in the middle that's known as our gateway address. Now this address, we can actually arbitrarily define it whatever we want. Sometimes people will use 254 as the gateway address. Most of the time they'll use a .1 as the gateway address. But you can actually define it any number you want. A gateway is just a host, but it's a way that another host knows how to get that packet off of the network onto another. So that's the specific part that we need to know about the gateway. But there's always one host at the gateway. In this case, we're going to set it to be the first address, and we're going to call it our gateway. Just remember, the gateway can be any other number. It doesn't have to be one. So the number of hosts that we have available in this network is 254. One of them is the gateway. So we're going to use this square right here to represent a network that has 256 IP addresses, of which it is comprised, including the boundary and the broadcast. It's a /24 in this case. And what we're going to do is we're actually going to add a bit to our network side of our address, which leaves one bit less for a host side. I remember when we talked about creating, counting in binary, we talked about actually numeric values that were associated with these bits. So what actually ends up happening is when we take one bit away, we split this network in half. So now I have a network that contains actually 128 and 128. So I'm actually cutting it directly in half. Now the thing about the subnet is that the subnet boundary is still the same. My first boundary of this subnet is still 192.168.1.0. But my slash notation is different. Whereas in the whole network, I'm a /24. In each one of these networks, I become a /25. So a /24 always consists of two /25 networks. The same thing with a /23. It consists of two /24 networks. We can work these numbers all day, and I would encourage you to take out your doodling sheet of paper and work through this over and over and over until you are well versed in it. But I'm going to write down the network boundaries so you can see them. Here's my first network boundary. I'm going to start on a 0. And I'm just going to show you the range. This is my network side of my address. This is my broadcast address because it's the last address in the range. And now, this becomes my new boundary. So, remember what we have right here is we have our original broadcast address of our /24 network. So now we have two networks. These are both broadcast addresses. And these are both network boundaries. In this case, I've counted by 128 in order to get there. If I subdivided this network again into 4 parts, each half would have 64 addresses. And I could count by 64. I would still have the same total number of IP addresses, but I'm subdividing it into smaller and smaller groups with my network boundary beginning at 0, and in this case, it would go to 64. It would go to 128. It would go to the next number, which is 192. And it would continue on. My boundary would allow me to create smaller and smaller networks. And so that's what we do with our IPv4 subnetting. Is we wanted to utilize our IP address space to create create groups that will handle the number of hosts that we need and no more. So we want to be efficient in our address space, and this is how we do it. Thank you very much.